industry leaders like Elon Musk predict that bipedal humanoid robots will eventually become a multi-trillion-dollar industry. Realizing that scale requires these machines to perform economically valuable work in the real world. Figure AI recently tested their F.03 humanoid model in a live logistics environment. The parameter for the test was a standard 8-hour warehouse shift. The test did not stop at 8 hours. The machines kept working, running 25 times longer than the original plan. For 200 continuous hours, the robots operated without a single mechanical failure or system crash. This timeline shows the scope of that run. The 8-hour target was surpassed by a reality of 250,000 packages sorted without rest. The fleet covered the equivalent of 25 consecutive human shifts back-to-back, operating through multiple day and night cycles. This test validates the technical viability of continuous, multi-day machine labor on a live warehouse floor. The endurance test took place in a massive fulfillment center, exposing the robots to the unpredictable variables of a live logistics environment. The intelligence driving the hardware is a system called Helix 02. It's a unified neural network that integrates vision, touch sensing, and whole-body control into one model, allowing the robot to manage balance and object coordination simultaneously. Under the Helix system, F.03 robots identified and placed a package every 2.6 to 2.83 seconds. That pace brings the machine to near parity with the speed of a typical human worker. To maintain that speed for 200 hours, Figure AI used an autonomous fleet rotation system. When a robot's battery runs low after about 4 hours of work, it walks to a wireless dock integrated into its feet to recharge. As the depleted robot exits, another unit enters the workstation, immediately taking its place. The fleet manages this rotation without human intervention, removing the concept of downtime from the operation. By addressing both the coordination requirements of the task and the energy requirements of the hardware, Figure AI has demonstrated a labor force that functions without biological fatigue. To contrast the machine's endurance with human physical limits, the company staged a 10-hour head-to-head package sorting race between the F.03 and a human intern. The human competitor, an intern named AIM, followed California labor laws, which required him to take both meal and rest breaks during the shift. This chart shows the final score. The intern won, sorting 12,924 packages against the robot's 12,735. However, maintaining that pace for 10 hours came at a high physical cost. The intern reported that the repetitive motion of sorting left his forearm physically wrecked. Seeing the physical toll required for a human to barely edge out a first-generation robot, Figure CEO Brett Adcock posted a stark prediction. This is the last time a human will ever win. The intern reached his absolute physical ceiling to secure that victory. For the machine, a 2.8-second sorting pace is simply the starting point for future software iterations. The data from this test allows warehouse operators to begin calculating the exact return on investment for a 24/7 robotic worker. For a logistics company, a single machine that covers 3 human shifts a day while requiring 0 benefits alters the math of labor costs. Figure AI is already scaling production to meet this anticipated corporate demand, with their Bot Q facility now producing 1 new humanoid robot every hour. This shift presents a path to eliminate the body-wrecking, repetitive manual labor that has traditionally defined the logistics industry. It also creates a scenario where millions of logistics workers may find their primary livelihoods directly challenged by machines that never tire. The 200-hour test demonstrated that the technical barriers to autonomous, multi-day logistics are falling. The next challenge is not whether the machines can do the work, but how the economy adapts as they are deployed.